Welcome to the fourth video on the unit on linear relations. In this video, we're going to be learning how to graph linear equations. And as you can see here, we've got two simple steps. The first thing you need to do, you're given, this is an example when you're given an equation and you need to graph it. So the first thing you do is complete a table of values based on the equation. And then once you've done that, all you need to do is plot the resulting points on a Cartesian plane. So let's go ahead and take a look at an example and try this out. So over here we have the question, graph the equation y equals 1 minus x. So I'm going to start off by creating a simple table of values over here. Start with our x values on the left and our y values on the right. And now basically you can choose any values of x. Usually a good starting point is 0 because that's simple. And then we just go up by 1. So I'm going to give 4. We're going to plot 4 points, so I'm going to give 4 x values here. So we've got 0, 1, 2, and 3. Now the tricky part is finding out the y value that corresponds with each of these x values. But the trick is to simply look at the equation you're given and see what it says. So this equation says y, our y value, is always going to be 1 minus whatever the x value is. So in our first number, when x is equal to 0, our y value will be 1 minus 0 because our x value is 0. Again, if I write that out, our y value is going to be 1 minus x, which in this case is 1 minus 0, which is simply 1. Okay, next we need to figure out what's the y value when x is equal to 1. So in this case, where y equals 1 minus x, this time our x value is 1. And what is 1 minus 1? 0. So we get a value of 0. Okay, now if x is equal to 2, the equation would be, well, what is 1 minus 2? And that gets us an answer of negative 1. And finally, when x is 3, we would do 1 minus 3, which gets an answer of negative 2. And you'll notice a pattern here. You can see that this actually is decreasing by 1 each time. And that's the great thing about linear equations, is that they always follow a pattern like this. Now that we've finished the first step, we've created our table of values, what we need to do is plot these points. Because you see, when x is 0 and the y value is 1, what that translates to, if you're used to seeing an ordered pair like this, 0.01. And on the Cartesian plane, that would be right there. That's our point. Okay. Next, the point 1, 0, or 1, comma 0, would be right here. Hopefully you can see that okay. And then after that, we've got the point 2, negative 1, which is right there. And finally, 3, negative 2, which is right here. And this is a good sign that the points we've just drawn create a straight line. If they created a curve or something that wasn't quite straight, you definitely would have made a mistake, because linear relations are all about creating straight lines. That's what's called linear. It creates a line as opposed to a curve. Now to finish off, technically you should connect these dots, and we draw arrows on each end to show that this pattern will actually go on forever to infinity. Okay, I think we'll try one more example, and that'll be it for this video. Let's just head on over here. Okay, graph the equation y equals negative 1/2 x plus 1. So I wanted to give you a bit of a tougher example here. Now again, we're going to start off by creating our table of values. So I'm just going to create a little table here with our x value on the left and our y's on the right. And again, we can pick any x values we want here. I'm just going to do the same as before, starting with 0 and going up to 3. Okay, now the fun part, we got to figure out our y values. So, our equation says to find our y value, we need to take the number or the fraction negative 1/2, multiply it by the x value, and then we add 1 to that. So let's go ahead and try that with an x value of 0. And I'm going to write this out just to make sure we don't make a mistake. So y equals negative 1/2 x plus 1. Now, in this first case, our x value is 0. So what I'm going to do is, instead of writing x here, I'm just going to replace it with a 0 in brackets because it's being multiplied. Okay, and now if we were to solve this, I know that negative 1/2 times 0 would simply be 0. And if I add 1 to that, well, 0 plus 1 is just 1. So our y value in this case is 1. And actually, I'm going to go right ahead and plot that point right off the bat. So 0, 1 would be right there. Okay, next up. When x is equal to 1, let's figure out what our y value would be. So we're going to take negative 1/2, multiply it by 1, and then add 1. Well, negative 1/2 times 1 is easy. That's just still negative 1/2. And if we do negative 1/2 plus 1, that would actually become positive 1/2. So just 1/2. Or 0, you could think of that as 0.5. Now, if we're plotting that, it's going to be a little bit trickier just because this graph here is a little small. 1 and then 1/2 would be right around there. I hope you can see that. So halfway between 0 and 1, obviously. Okay, next point is when x is equal to 2. So in this case, we're going to take negative 1/2. This time we're multiplying it by an x value of 2, and then we're adding 1. So negative 1/2 times 2 would become negative 2. And then if we add 1 to that, oh, sorry, no, that was my mistake. Negative 1/2 times 2 is actually negative 1. And if we add 1 to that, we would get 0. So our y value in this case is 0. So if we plot that point, 2, 0 would go right there. This is looking good. It looks like we're getting a straight line here. Now let's get one more point. When x is equal to 3, what would y become? Well, let's actually take a quick guess here. I can already start to see a pattern forming. The y value is going from 1 to 1/2 to 0. So it looks like it's subtracting half each time. So if that pattern continues, if we subtract half from 0, it would actually become negative 1/2. Although I am going to do the math just to confirm that. So we would take negative 1/2, just like the equation tells us to. We're multiplying it by our x value, which is 3 in this case, and then we would add 1. Negative 1/2 times 3 would become negative 3/2, or we can think of it as, well, yeah, we'll just do that. And then if we had to add 1 to it, if you type that in your calculator, you would in fact get negative 1/2. So that is in fact correct. And if we were to plot that point, it would be right around here. And then just to finish up, we would connect all of this in a line with our arrows. All right, that's it for this video. Hopefully it helped.